Welcome. This is Mr. Perry with part 2 of Miss V's series, Atoms, Elements, Periodic Table, and Chemical Stuff. A little bit about our world and the universe. Let's quickly review what we covered in episode 1. And we talked about the atom, the smallest non-living unit in the universe. What are atoms made of? Electrons, which hover around the atom's nucleus, and they have no mass and have a negative charge. And the symbol for electrons is a small e with a negative sign. The atom also contains a nucleus, which has protons, which are positively charged particles that have mass, and the symbol for protons is a capital P with a plus sign. In addition to that, we have neutrons, which are particles that have zero or no charge and have mass. And the symbol for neutrons is a small n with a zero. Let's move forward. Once again, we're going to talk about electrons, which are negatively electrically charged particles that orbit or circle around the atom's nucleus. The electrons have no mass, and their symbol is a small e with that negative sign. Now, they travel in different orbits or paths or energy levels around their atoms, and these energy levels or paths of electrons are like layers of clothes that you might put on. The first electron levels are right outside the nucleus, and the other layers of levels build out from there. An important thing to know is that each level can only hold a certain number of electrons. Well, what is an element? An element is a substance made up of one kind of atom, and they cannot be broken down into a simpler substance. And each element has their own symbol that begins with a capital letter, like C for carbon, Ca for calcium, and H for hydrogen. You say, wait a minute, Mr. Perry. Calcium had a C and an A, but every element begins with a capital letter and only has one capital letter. Here are some common elements. We have nitrogen, N, oxygen, O, sulfur, which has an S, Fe, different, for iron, only one capital, K for potassium, Mg, magnesium, and Cl, chlorine. Well, let's take a look at the periodic table, which is a chart listing all the known elements of the universe. Dmitri Mendeleev, who was born in 1834, died in 1907, was a Russian scientist who created the periodic table. He also discovered several elements. He organized each tile in order of their atomic number. The atomic number, once again, is the number of protons and or electrons, and he noticed missing numbers. In this way, he was able to predict elements that had not yet been discovered. Let's watch, learn some more.
If you're into chemistry, you might have seen this table before, the periodic table of elements. Looks pretty complicated, doesn't it? Now we're going to meet the guy who came up with this table 150 years ago. He was a chemist, he was an inventor, and he was from Russia. His name was Dmitri Mendeleev. The periodic table is one of the most important tools in the world of chemistry. It shows the atomic properties of every element in our world in a format that's easy to read and remember. Like a lot of brilliant ideas in science, Mendeleev was helped by the hard work of scientists who came before him. As Isaac Newton put it, "If I have seen further, it is by standing on the shoulders of giants." If Dmitri was alive today, he'd be around 185. He was born in 1834 in Siberia in Russia. Little Dmitri was the youngest of 13 or 14 children, no one's quite sure. His mother came from a well-known family of local merchants. His father Dmitri was an educated man who was a teacher in a local school, but when Dmitri was still a little boy, his father went blind and had to give up working. This meant that to make ends meet, Maria had to go to work herself, and she started up the abandoned glass factory that belonged to her family. When Dmitri was 15, his mother took him out of the local school and travelled all the way across Russia from Siberia to Moscow to get him a better education. So it would have been a really big journey. When he finished school, Dmitri Mendeleev went back to school, but this time as a teacher and not a pupil. In his own time, he studied hard and he wrote a textbook called, you guessed it, Organic Chemistry. This won him a prize from the Petersburg Academy of Sciences. Now he was getting noticed in chemistry circles. I've just read Mendeleev's book, really good. Who's that guy Mendeleev? And he was soon made a professor at St. Petersburg State University. And a year later he became a doctor of science, and he was only 31. Looks like he's building up to something big. His personal life was not going quite so well. Around this time he got married to Fyodosva, a girl his sister knew, and she kind of pushed him into it. They did have 2 children, but they weren't very happy, and they stayed together for nearly 20 years. But by this time he'd fallen madly in love with his niece's friend Anna Popov. He was 47, she was 17, so you can imagine what her father thought, even if he was a very famous scientist. But they married, they were very happy, and they had 4 children. When he was a teacher at St. Petersburg University, he wrote a textbook for the students on his course. He was looking for a way to organise the chemical elements. Back then they were usually grouped by their atomic weight or by their property, whether they were a metal or a gas. One morning in 1869, after a good night's sleep and with the taxi waiting to take him to the train station, Dmitri Mendeleev made a set of 63 cards, one for every element known at the time. Silver, gold, zinc, copper, hydrogen, helium, oxygen, right up to 63. Like a fanatical card player, he spent 3 days organising and rearranging his cards and completely forgot about his train journey. And then he was so tired he went to bed. He later said, I saw in a dream a table where all the elements fell into place. The moment he woke up, he wrote it down on a piece of paper. As the brilliant French scientist Louis Pasteur said, fortune favours the prepared mind, and his life's work and the work of others had made him ready for this moment. Dmitri Mendeleev remained involved in science until his death in 1907. He was given lots of awards, 2 from the Royal Society in London and from Oxford and Cambridge. There's a metro station in Moscow named after him and a crater on the moon. Let's not forget element 101 that's called Mendelevium. So to recap, Dmitri Mendeleev, born in Russia, from tough beginnings, he got an education, he got interested in chemistry, and in 1869 he came up with the periodic table. And what's so great about the periodic table? Well, it organises elements according to similar properties, so in a glance, just a glance, you get a pretty good idea of what an element's going to be like. Spasiba, Dmitri Mendeleev!
Well, here we have a periodic table which was developed by Mendeleev, and as you can see, it has a lot of information. It breaks elements into groups and periods and puts this information on tiles where we can learn a lot about the individual elements. Let's take a closer look at the tiles. The periodic table, once again, made of tiles that contain the element's name, symbol, atomic number, and atomic mass. These tiles are arranged in rows and columns, and In this particular element, we see the number 29, which is the atomic number, which equals the number of protons and or electrons in the element. The middle, we have the chemical symbol, which is Cu in this case, the first letter being capital. And on the bottom here, we have the atomic mass. When we think of the mass, we think of that nucleus where we have those protons and neutrons clumped together, and they make up the weight of that particular atom, or the mass as it's more often called. So we have the atomic mass, the atomic number, and the chemical symbol. Now, there are many forms of the periodic table. Some are color-coded. Some may have the atomic mass or the atomic number in a different part of the tile. So remember that the mass is usually a number with a decimal point, as you see the 63.5 there on the bottom. Here's how to read a periodic tile of an element. And in this example, the element is oxygen, you see there to the right. The number of electrons is 8. The number of protons is also 8. Why is that? Because the number of protons always equals the number of electrons. You have 8 in the outer shell and 8 in the inner shell inside the nucleus. And the number of neutrons in this case is 8. So we have the atomic number, which is the number of protons and or electrons in that element. We have the symbol, a 1 or 2 letter abbreviation of the element's Latin name. And once again, the first letter is always capitalized. And we have the atomic mass, which is the average mass of the element with atomic mass units. And here's a little practice on reading a periodic table's tiles. What do we have here? We have carbon, which is C, as we see there. The atomic number, as you can see at the top, is 6. Carbon's atomic mass is 12. It was 12.011, but it was rounded. And carbon's number of protons. Well, we look at that atomic number. The atomic number and protons, always the same, equals 6. And carbon's number of neutron, it's equal to the atomic mass on the bottom there, which is the 12, minus the atomic number, which is the 6 on the top. So neutrons for this carbon atom or carbon element is 6. So there you have it. We have a fair amount of information here. And if you don't quite get it, if some of the things seem a little confusing, just back your recording up and listen to it again. You keep trying and you'll get it. It's not too bad. All right, let's get it done.